Hi folks, welcome back. In the previous video, we talked about what is service mesh and then the different service mesh offerings, and then one of the popular service mesh offering called Istio. We talked about the architecture of Istio and like how the different control plane and data plane working and all. Now let's come into the big picture, which is like to talk about cloud service mesh. So before understanding what is cloud service mesh, let's try to focus on what are the different service mesh offerings which is provided by the Google. So Google used to when I say used to, because now it's all about cloud service mesh. That is the reason why it used to provide two different options for service mesh. One is Anthos service mesh, another one is a traffic director. So if you see, how these two are different is like the Anthos service mesh is basically, originally it's for Istio based APIs. It's see the thing is Anthos. If you know the Istio architecture, trying to I mean understanding the Anthos architecture is not much complex because it's purely leveraging the complete Istio features. If you go to traffic directors, it's completely the GCP API based. So these APIs are specific to GPI. I mean the GCP, and these are like present only on the Google Cloud environment. Whereas in Anthos Service Mesh, it supports both for Google Cloud and non-Google Cloud environment. So when I say non-Google Cloud environments, for example, if you see the original use cases which were implemented in the previous set of videos where spinning up the GK enterprise cluster on AKS environment and I mean sorry the Azure environment, and spinning up the GK cluster on Amazon and all other on-prem environments and all. So that's about Google Cloud, non-Google Cloud environments. So this Anthos service mesh is as mentioned in this presentation, it's like it's hosted and I mean when it is hosted on GCP, it is completely managed, as well as when it is hosted on any other non-GCP environments. For example, if you install GK on Azure and GK on Amazon, the control plane, whatever it is, will be on in cluster, whereas that is also the managed and all. That is what it is claiming in this documentation. But when you go to cloud service official documentation, the in cluster implementation, it is saying it is unmanaged. There is quite, confusion here, and some statement seems to be contradictory, for which I'm trying to gather more information from the Google. Maybe in the upcoming videos when I perform the live demonstration of various implementation of the uh, the cloud service mesh, right? I will clarify it for all the audience. So in case of traffic director, it's specific to Google Cloud environment as I mentioned, and it is completely managed and hosted on GCP, and it supports multiple Google Cloud runtimes like your Google Cloud Run, and then Google Kubernetes Engine, etc. So in case of Anthos Service Mesh, it's more for the platform admin guys or service operators, those who manage the entire platform. Whereas in Traffic Director, it involves a lot of work for network admins. That's the high level comparison or overview you can say for different offerings which Google is providing for Service Mesh. Let's go to the specific one about the Anthos Service Mesh, and let's try to understand how it is. So as I was mentioning in the previous slide, if you know the Istio architecture, then it's almost 99% it is same for the Anthos services, because after all it's built on top of Istio, open source Istio. So Anthos service mesh, it's offered in two flavors. One is completely managed, the other one is in cluster control plane. Let's try to understand what are the differences. So in case of completely managed, as you can see in this diagram, your control plane is completely hosted and managed by Google itself, whereas your data plane sits on the customer cluster here, I mean the user cluster specifically, and the architecture is very straightforward. if you know the Istio architecture, as I said, it's same. It's like you have your proxy sitting on each of the microservice, and then that proxy is responsible for communication between the microservices, and your control plane manages all the the health checking, service availability, service discovery, traffic splitting, load balancing, that the typical service mesh responsibilities, whatever control plane is doing in the Istio, same thing is leveraged here. Whether the certificate management, mutual, TLS communication, encryption, everything. So that's about fully managed, Anthos service mesh architecture. Whereas in case of an in cluster architecture, you see here that your control plane is also sitting in the user cluster, or the customer cluster itself. In case of completely managed, the Google is responsible for managing your complete control plane, its upgrades, patches, everything. Whereas in case of in cluster architecture, the control plane component Istio-D, which again in the Istio architecture I was mentioning about, like how post 1.5 version of the Istio, like Istio-D is completely responsible. All other components like Galley and your I mean other components, whatever was there as a part of the like Citadel and all those things, are now completely as a part of the control plane HTOD itself, and that itself, is responsible for all the management stuff. So same, you have a proxy sitting on each microservice, which is like responsible for the traffic within the cluster. If you see in the data plane within the mesh traffic between it's happening with the help of proxy. So that the typical service mesh features traffic, flowing, routing, encryption, security, same applicable here as well. So there is nothing much extra that it is doing, except that the control plane is sitting at the user cluster itself. This is about Anthos service mesh architecture, two different flavors at the high level. Now let's come to the traffic director. So what is this traffic director and how it looks like? So again, this is also Google's service mesh offering. So in case of traffic director, it's like it's a fully managed global control plane. When I say global, it is split across the regions. So let's assume you have your in this specific diagram itself, if you have your front end, let's say sitting at one US central region, and then your shopping cart is sitting maybe on the US West, and and payment maybe somewhere in the Asia. This traffic director is responsible for managing all these microservices load balancing at the regional level. When it receives the traffic, whichever the region near to that user, the traffic will be redirected. I mean, we will see this in detail with one example in the upcoming slide, but this is what at the high level, and it supports both for I mean multiple runtimes. Like it supports for your Google Cloud Run, and then it supports for GKE, both. So that's about the high level architecture for the traffic director. Now let's take one specific example and try to understand different components or features of this traffic director. So if you see, let's it's mentioned that the different capabilities of the traffic directors. So it's like the global load balancing, centralized health checking, load based auto scaling, and built-in resiliency. Let's try to understand these in a specific example. So if you see this example, it's a simple demonstration for this traffic director by taking three different services which are present in two different regions. So in this particular example, if you see the front end, shopping cart, and the payment are three microservice, and these microservices are sitting in US Central one and Asia Southeast one. It's available in two different regions. Now let's try to understand what are these different features of traffic director is working. I mean, how it is working here. So whenever a user sends kind of an request for this microservice, the request is coming from this user. If you see in this diagram, there is a user who's sitting in the California, user who's sitting in the Singapore. If the request comes from a user sitting in the California, then since the traffic director is globally spreaded, it's like if it's balancing the traffic for both in three different regions here for all these, I mean two different regions for all these microservices. So the request which is coming from the user in the California, the traffic director is intelligent enough to send this request to the closest region. So in this case, the closest region for the user who's sitting in the California is US Central 1. So the traffic will be sent to US Central 1 in this case. So the another, I mean, similarly, the another user here, which is, who's sitting in the Singapore, if he or she sends the request, then the traffic will be sent to the nearest region, which is in this case is southeast one. So that's about the global load balancing mechanism. So okay, let's take the scenario where all of suddenly when the user from the California sends a request, what if a particular microservice, say for example the shopping cart is suddenly unavailable? What happens in that case? So if you see in this diagram, so then in that case, traffic director is very smart enough to do to test this service unavailability, and automatically it sends that request to the the microservice which is running in the southeast one. So how it is possible? Because the traffic director does the central health checking, because it has the central health checking system. So usually in a typical service mesh, so how it happens is each of these proxies sitting on the individual microservices does this health checking. I mean, it does check all the service these microservices which are sitting their availability and all. It constantly does this health checking. Because of this, if every proxy which is sitting in every microservice start doing this, it's just an additional overhead traffic, and because of this it causes the impact on your workload as well. So that is the reason why what traffic director does is it does all the centralized health checking, and then it publishes that results to each of these proxies. So since that it's already known that this traffic director is already aware that this region is not available. It automatically I mean this service is not available in this region. Automatically the traffic will be shift to the next one. In this case, it's southeast one. So that's the another beauty about this traffic director. So another wonderful thing about traffic director is it's doesn't do auto scaling whenever it is required. Rather than that, what it does is advanced scaling it does. For example, if it gets a signal from the traffic director that it is receiving this much of a load, what it does in one shot, it will scale your entire microservices to, for example, 2, 4, 6, whatever, based on the traffic signal, how much traffic it is expecting. And it scales that, rather than waiting at the individual request when it comes and wait for that particular period of time where the machines are getting scaled and then serve your request. No, that kind of time saving and everything, it's automatically done. And in case of in resilience, since it is all managed by the Google, you need not to worry about traffic director's uptime, whether it is available or not, whether it is properly balancing it, all those things. You need not to worry, because it's a completely managed service by the Google, and they will take care. That's all it's mentioned in this different capabilities slide. All right, now let's try to understand what is this cloud service mesh. So now you already understood the architecture of the two different cloud service mesh offerings by the Google. One is like your traffic director, another one is Anthos service mesh. So what is this cloud service mesh is? The cloud service mesh is just a unique combined version of both uh, your Anthos service mesh and traffic director, you can say at the high level. This is just a simplistic definition. It's just leveraging the features of both traffic directors and Anthos service mesh, and it is offering you this combined feature at one uh, place. So that's about a service mesh high level definition. So if you see this architecture diagram at the top, you see that the typical cloud service mesh consisting of three different components, which is your like the control plane, which is sitting at the middle, and then you have your cloud service mesh data plane, and then cloud service mesh services. So we will go in detail about this in the upcoming slide. So, but if you see like how by leveraging this traffic director and Anthos service mesh features in one place looks like with the help of cloud service mesh. So in the below diagram, if you see, it's extended beyond the Google Cloud for even half Google Cloud environments, like having your GKE on Azure, GKE on Amazon, or any other on-prem environments. If you see, it's like it's extra. Your control plane is extended beyond the Google Cloud. So one key thing you have to understand here, when you implement the cloud service mesh, by default, for all the the Google Cloud environments, the implementation will be Traffic Director. Even though it's deployed on the Istio based applications and all, but your Traffic Director control plane implementation type would be Traffic Director, whereas in case of off Google Cloud, your control plane implementation type would be IstioD, is by leveraging the open source IstioD. Of course, that does not mean that Istio and its APIs, its gateway components doesn't support in the Google application. It does. It does. On top of that, since your load balancer is at the global level, so traffic director would be taking complete control there. So that is the beauty of cloud service mesh, the leveraging both. Since the multiple cloud runtimes options are available here at the traffic director, so that features also, as you can leverage in this CSM. So in the manage runtime, if you see on the Google cloud platforms, you have your GKE, GCE, Cloud Run and all. Similarly, if you come to off GCP, you can do it on-prem as well as a multi-cloud. So the data plane implementation, it's simple. The NY proxy for Istio based kind of an application. You have this proxyless kind of stuffs as well for gRPC. DPV2 has come from traffic director. So don't worry much about these things. These are just implementation types. So as an implementer, you would just need to choose whether you're going with your NY type, or you're going with the proxyless gRPC. It's up to individual users, but the popular choice always would be NY based proxy, and it does support both for L4 and L7 kind of load balancing at the gateway level. So that's at the a typical high level. It looks like the combined features. Now let's talk about the individual components of this service. I mean the different the structures, the pillars of the cloud service mesh architecture. So if you see in this diagram, so first let's focus about the cloud service mesh control plane. How it looks like. So as you see in this diagram, the Google hosted and managed, and then how this Anthos service mesh, when we talked about like how the two different flavors, like one is a Google managed, another one is the in cluster. So in this case, since the cloud service mesh is a combination of both the Anthos service mesh and the traffic director. So again, in this diagram also, it's quite unclear because Google here it is claiming that in case of Google hosted and I mean, in case of cloud service mesh in Google, I mean in Google, when I say in Google, just for GK environments on GCP, so it is completely hosted and managed. There is no doubt in that because it's straight away anybody can understand because it's after all the Google product and completely it is managed and all. It's totally makes sense. Now, in the second scenario, scenario or the right section of this control plane, you see that for off Google Cloud environments, which is like your Azure, Amazon, and all, it's purely Istio based, and it is like in cluster. That means your control plane for the cloud service mesh is sitting within the user cluster, and it is Google managed. In this diagram, it is showing Google managed, whereas if you go to the official documentation of cloud service mesh from the, of course, this is also official. These screenshots are picked from the official Google Cloud Conclave, 2024, where the Cloud Next event, where they were giving the demo. I would be giving the reference link, all this, where did I refer and all in the upcoming slide. So if you see here, this is the place where I have acquired this knowledge and the references, everything I have mentioned here, because after all, it's a Google stuff, and they are the one who uh, gave the explanation about this. So this screenshot just for the explanation I have picked from here, and I'm explaining you. So, but here they say that, let's go to this slide. Yeah, here they say that of Google Cloud environment, it's like in cluster. Of course, it's in cluster. That makes fully sense. And Google managed. But in the official documentation, there is nowhere where we can find that implementation methods, because in the explanation clearly says in cluster and unmanaged were of Google Cloud. So there is some sort of confusion here, because there is not clear indication anywhere that enough Google cluster, I mean, enough Google cloud environments it is managed. Again, I'm trying to find more information from the Google on this. As and when I get more information, I'll update to all of you folks. So see here, same thing on GCP it is hosted, whereas in off GCP it is in cluster. I mean the control plane. So on GCP, the Google is responsible for all the upgrades and patches. Yes, whereas in off GCP, it is managing the upgrades, and this is the statement which is causing contradiction for me as of now. But yeah, let's try to find more information from the Google in the upcoming sessions, and I'll share with all of you. So again, since even though in the Google Cloud environments, I was mentioning that it would be traffic de-implementation, but still it supports all the Google and Istio based gateways, API implementations, and plus the gateway classes as well. Whereas in off GCP, you see it supports only the Istio and Istio based gateway APIs and all. I mean the core gateway API client, everything, virtual service, all those things, the typical Istio features. So that's about the control plane. Now let's come to the data plane. So it's available in three different, just like how the Istio, it's available in three different modes: the sidecar mode, ambient mode, and gRPC proxyless mode. It's more, it talks more about the how proxies can be leveraged, how we can reduce the overhead of the proxy and all. So usually what happens in a typical proxy mode environment is, since it just adds an additional container to the existing application container in a pod, when it restarts, it's just an additional overhead to restart this container as well. That would take an extra time and all. So that is the reason why people have come up with this proxyless kind of methods, which is typically this gRPC is one kind of an implementation for that. It works on this XDCA protocol and all. So so you focus more towards this sidecar and gRPC proxy. So this ambient is in between. It sits, in the middle, whereas it takes some features from the sidecar, some features from the proxyless, and it sits in the middle. So I mean, you have these three options, and it's up to the individuals which options you can use and all. Maybe when we implement this, and the hands-on sessions, the various CSM implementation on the GCP and non-GCP environments, the multi-cluster, hybrid modes, and all. Let's try to understand more towards that in the upcoming implementation sessions. So during that time, I think you will understand more about these different CSM modes. And the service mesh, services, like you have your mesh CA typically, which is Google managed, whereas for all the Istio based applications and all, you have your Istio CA. So you are free to choose any of the CAs plus any of the custom CA also if you want to choose and all. The service mesh implementation supports that as well, self-managed CAs and all. On top of this, you have your SLOs, all these integrations, alerting methods, everything that you can see in the the monitoring Google Operations tools. And you have your policy controllers and all the other security in steps, whatever you want to see and all that also you can see. Those are just an additional components which are leveraged with the help of this service mesh services plane. So this is about CSM at the high level. Okay, let's try to understand more about this, cloud service mesh from the official documentation. So if you go to, sorry, cloud service mesh official documentation, here it is. So you would see, the same, the typical service mesh kind of a features, which I already explained in the slide about this traffic management, the observability insights, security benefits, and all. Now, here's the interesting part, the deployment options. So you have following deployment. This is what I was referencing inside, in my slide. So on Google Cloud, manage cloud service mesh, which is like manage control plane and data plane for GKE, and of course manage cloud service mesh for compute engines and other things, because one of the key features is supporting multiple runtimes. Now here is the thing, in cluster control plane for GKE with Istio APIs as well, this also is available, but Google never encouraged this, and they wanted to go for for every individual users to suggest that go with the managed cloud service mesh, which takes care of both your control plane and data plane. Now here is the thing, of Google Cloud, it is in cluster. That means your control plane is sitting within the user cluster for Kubernetes with Istio APIs. This is known, but whether it is managed or unmanaged, nowhere they mentioned. However, if you come down here, the control plane implementation section, you have your for the existing users. When I say existing user, this is because the cloud service mesh is a new product, right? You mean prior to this, you already had Anthos service mesh traffic director. So the users who are already there in the Anthos service mesh and traffic director, how they can migrate to cloud run and all, that is something is targeted for those audience here. Now here is the thing, cloud control plane implementation for new users, which are we, because we are just starting from the scratch. If you are planning an off Google Cloud configuration, which is like installing the GKA on Amazon, installing the GKA on Azure and all, you are choosing cloud service mesh in cluster unmanaged control plane. That means here Google is claiming that off Google Cloud it will be in cluster control plane. That makes really sense because the control plane is sitting within your user cluster, but it is saying here it has an unmanaged control plane. But in the Google Cloud Conclave, which I was showing in the screenshot, like their Google Cloud Next official introduction to this cloud service mesh and all, they're claiming that it is managed. Even the control plane is managed on the uh, of Google Cloud environment. So this is quite confusing. I mean, I'm trying to find more information on this, but let's wait for some more time and see what we get. So if you go here, these are all the steps for implementing this cloud service, which I'm going to discuss in detail in the upcoming session. So let's go to outside Google Cloud. So here install cloud service mesh. If you go, so here it is very clear. uh, this page explains how to install unmanaged in-cluster cloud service mesh for Kubernetes workload of Google Cloud. This seems to be like, I mean, those who watch, it's very straightforward that it is saying that it is in cluster. Yes, that makes sense, but it is unmanaged. That is what it is mentioned here. But they are claiming that it is managed. So I don't know. We need to find out more about this and then understand. It's quite confusing in this documentation. All right, with this, all right, with this, let's conclude this, session. And in the upcoming session, we will, in the upcoming videos, we'll try to see the various uh, installation, or implementation methods for this cloud service mesh within the Google Cloud and outside the Google Cloud. And let's talk about, this. Multi-cluster setup and multi environments as well, everything we will see and try to understand more about this. Thank you folks, thanks for watching this. Stay tuned and subscribe to my channel. Thank you.